Something is stirring in the darkness just beyond the sun's protective glow. Something vast, ancient, and impossibly powerful. And every new telescope we point into that cold frontier whispers the same terrifying question. What exactly is hiding out there? If you looked up at the night sky right now, you'd probably think you were seeing empty space. Cold, silent, untouched. But that illusion is the biggest lie the universe has ever told us. Because the space just outside our solar system is not empty. It's not quiet. And it's definitely not safe. In fact, we're surrounded by a cosmic structure so violent, so strange, and so colossal that scientists didn't even realize we were inside it until recently. A structure born from the deaths of some of the most massive stars our galaxy has ever known. A structure that has shaped the sun's journey, the planet's orbits, and possibly even the evolution of life on Earth itself. And that's just the beginning. Because beyond this structure, beyond the invisible wall that surrounds our solar system, scientists are discovering anomalies, distortions, and energetic fingerprints that defy everything we thought we understood about the Milky Way. Some believe it's the remnant of a long-dead supercluster. Some think it's a gravitational scar left by a wandering rogue star. And others think something far stranger is lurking there. But before we uncover the truth hiding just beyond our cosmic doorstep, we need to understand how we stumbled into one of the most unexpected discoveries in the history of astronomy. The invisible trap we never knew we were in. Imagine this: 15 massive stars, each one larger than anything in our solar system, each one burning with unimaginable fury, detonating one after another in a chain of supernova explosions. Not separated by millions of years. Not scattered across a distant arm of the galaxy. No. These titanic blasts happened close together, in both space and time. And when they went off, they didn't just light the galaxy. They carved into it. They tore open a wound in the interstellar medium, an enormous cavity, a cosmic crater, millions of degrees in temperature and hundreds of light-years across. Shockwaves ripped through space, sweeping aside clouds of gas and dust like a hurricane ripping through a quiet town. This wasn't just destruction. This was creation by force. Scientists now call structures like these hot bubbles. A beautiful name for something born from chaos. But here's the part that should make every one of us shiver. We're not approaching this bubble. We're not orbiting around it. We are inside it. And we're moving straight toward its heart. Think about that for a moment. Our entire solar system, our planets, our history, our origins, exists inside a region of space forged from ancient stellar death. Every second of your life has taken place inside the shockwave aftermath of 15 supernova explosions. And until the last few decades, humanity had no idea. The discovery no one expected. Back in the 1970s, astronomers noticed something odd: low-energy X-rays hitting Earth from every direction. It didn't make sense. Something had to be producing them, and whatever it was, it surrounded us. But was it local? Or something much larger? For years, the data was confusing. Some scientists thought the emissions were coming from interactions between solar wind and neutral atoms nearby. Others suspected something far more dramatic: a giant bubble of million-degree plasma, the leftover remains of multiple supernovae. But there was no way to prove it. Not until NASA launched the DXL mission in 2014. That mission confirmed what many had whispered for decades. Only 40% of the X-rays were coming from inside our solar system. The rest? The other 60%? They came from outside, from a vast field of superheated plasma that wrapped around us like a cosmic cocoon. This was the moment the astronomy world gasped. We are living inside the smoking ruins of multiple ancient supernova explosions. But the discoveries didn't stop there. Earth's geological time capsules reveal the truth. Deep beneath our oceans, in the quiet dark crust of the seafloor, scientists found something impossible. Iron-60. A radioactive isotope that can only come from one place: supernova explosions. Earth does not produce it. Meteorites rarely deliver it. But supernovae? They create it in enormous quantities. And the seafloor didn't just contain Iron-60. It contained layers of it. Like the universe had left us a trail. A cosmic breadcrumb path pointing to the exact time these ancient deaths occurred. Two major spikes in Iron-60 deposits, each one marking a wave of supernova material washing over Earth. Imagine that for a moment. Earth being dusted by the ashes of dead stars. Star dust raining down across the oceans. Into sediments. Into rocks. Into the very timeline of our planet. It wasn't science fiction. It happened. And the planet kept the receipts. But now, something else is going on. Because here's where things get unsettling. The boundary between our solar system and the rest of the galaxy, the so-called edge, isn't a simple border. It isn't a clean transition. It's a battlefield. A war zone of magnetic fields, charged particles, and shockwaves. And recently, spacecraft like Voyager and IBEX have detected anomalies. Regions of unexpected pressure. Mysterious ribbons of energetic particles. Density changes that make no sense. And structures that seem to twist in ways our models can't explain. Something is shaping this region. Something is influencing our heliosphere. Something is pushing, pulling, or distorting the very environment we move through. What could it be? Dark matter filaments? A nearby rogue star? A remnant black hole? The next wave of an ancient supernova shock front? Or something entirely new? Hold that thought, because the answer might be stranger than all of them. And in the next part, we'll dive deeper into the cosmic structures beyond our solar system, and reveal why scientists are suddenly rethinking everything they thought they knew about the boundary between our sun and the galaxy around it. Just when scientists thought they understood the structure beyond the sun, new data emerged. Data so bizarre that it forced them to rewrite entire models of our cosmic neighborhood. Because what lies just outside our solar system isn't behaving the way space is supposed to behave. For decades, astronomers imagined the edge of the solar system as a clean and simple frontier, like a bubble gently floating in the ocean of the Milky Way. But reality is never that kind. And as our instruments improved, as the Voyagers broke through the sun's influence, and as heliophysics matured into a true science, a disturbing truth began to emerge. The edge of our solar system is warped, twisted, pressurized, and something out there is pushing against us. But to understand why, we must first understand the structure that defines our cosmic boundary. The heliopause isn't what we thought. Imagine the sun not as a peaceful sphere of light, but as a colossal engine blasting out a hurricane of charged particles in every direction. This stream of energy, called the solar wind, carves out a protective bubble around us. This bubble has a name: the heliosphere. Inside it, we're safe from most cosmic radiation. Outside it, space becomes feral. At the outermost edge lies the heliopause, the point where the solar wind collides with the interstellar medium, like two invisible oceans crashing into each other. For years, models assumed this border was round, smooth, predictable. But that fantasy shattered when Voyager 1 crossed the heliopause on August 25, 2012. The measurements didn't make sense. Nothing matched the models. The transition wasn't smooth, it was chaotic. The energy levels were wrong. The magnetic directions didn't line up. Scientists had two options: assume the instruments were failing, accept that their understanding of the heliopause was fundamentally flawed. Voyager 2 confirmed it years later. Both spacecraft detected sudden spikes in plasma density, unexpected magnetic intensities, strange fluctuations in cosmic ray pressure, a boundary that acted more like a storm wall than a smooth shell. These weren't random anomalies. They were signs of external pressure, of something pushing inward, something powerful enough to distort the sun's protective bubble. But what? Something is pressing on our solar system from the outside. The first suspect was the interstellar medium itself, the gas and dust that fills the galaxy. But the density wasn't high enough. The pressure wasn't strong enough. The numbers didn't add up. So researchers looked deeper. They modeled supernova shockwaves. They studied cosmic magnetic field lines. They simulated interstellar cloud collisions. And one possibility rose to the top, sending a ripple of unease across the scientific community. We may be moving through the gravitational aftershock of the local hot bubble's ancient supernova chain. Think of it like this. 15 supernova explosions didn't just clear space, they reshaped it. They twisted magnetic fields. They pushed matter outward in violent waves. They created filaments, cosmic scars, that still stretch across our region of the galaxy. And our solar system is plowing straight into them. This could explain the pressure, the warping, the magnetic distortions. But even that wasn't enough to account for everything. Because in 2009, NASA's IBEX probe discovered something so strange, so unexpected, that even the scientists behind the mission thought the data was wrong. They found a ribbon. The IBEX ribbon, the structure no one saw coming. Imagine a glowing, energetic band circling the entire sky, a cosmic arc of charged particles forming a perfect curve. That's the IBEX ribbon. At first glance, it makes no sense. It shouldn't exist. Nothing in heliophysics predicted it. Yet it's real. A mysterious structure aligned almost perfectly with distant magnetic field lines that thread through the galaxy like invisible rivers. And it raises a disturbing question. Why is the boundary of our solar system shaped by a magnetic field far outside our solar system? Because if something external is influencing the ribbon, then something external is influencing us. But that's only the beginning. When NASA upgraded IBEX with more sensitive instruments, the mystery deepened. Over time, the ribbon's intensity changed, brightening and dimming as if responding to something. Something dynamic. Something alive. Something interacting with us. But what? One hypothesis. The solar system is moving through a region of space where magnetic fields from the local hot bubble compress the heliosphere from one side, creating a glowing ribbon of energetic particles. Another hypothesis. An unseen interstellar cloud, or several, may be interacting with the heliosphere, pressing and stretching it like a hand against a soap bubble. And then there's the third hypothesis. The one scientists talk about quietly. The one that sounds like science fiction. The one that might explain the distortions, the pressure, the magnetic anomalies, and the ribbon itself. Could there be a gravitational giant nearby? Not a star. Not a planet. Not a black hole you could see or detect easily. But perhaps a dark, massive structure, like a filament of dark matter, passing near the solar system. Dark matter interacts gravitationally, but not electromagnetically. We can't see it. We can't touch it. But we can feel its influence. A dark matter filament, thin, invisible, stretching across the galaxy, could absolutely warp magnetic fields, alter cosmic ray flow, distort the heliosphere, create pockets of pressure, trigger unexpected particle emissions at the boundary. But is it likely? Not exactly. Is it possible? Absolutely. But the truth might be even stranger. Another clue from an unexpected source. In recent years, new data from Gaia, Hubble, and radio telescopes revealed something scientists had long suspected but couldn't prove. The interstellar clouds surrounding the solar system are moving and changing. We are drifting into a new region of space, a new environment, one shaped by the aftermath of the local hot bubble and the remnants of ancient supernovae. These clouds vary in density. They vary in magnetism. They vary in composition. As the solar system passes through them, the heliosphere compresses, expands, warps, and twists. Imagine a submarine diving through deep ocean layers, each layer pressing differently on its hull. That's us. That's Earth. That's the entire solar system. And right now, we are entering a region where the pressure is rising, where magnetic fields tighten around us, where anomalies multiply, where boundaries bend. But what lies beyond these clouds? That's the part scientists are only beginning to uncover. Because just past this interstellar region lies something even more mysterious. Something enormous. Something ancient. Something that may be influencing the shape of our cosmic neighborhood from a distance of hundreds of light years. And in part 3, we'll unlock the next layer of the mystery. The colossal structure beyond the solar system that scientists believe could explain the anomalies, the pressure, and the strange phenomena surrounding our cosmic home. Just when scientists thought the local hot bubble explained the chaos around our solar system, a new discovery shattered that confidence. Because beyond the bubble, lurks a structure so colossal it bends starlight, redirects cosmic winds, and might be the real force shaping our cosmic neighborhood. From the moment we learned that our solar system sits inside the ruins of 15 supernova explosions, scientists breathed a sigh of relief. Finally, an explanation. A cause. A story that wrapped everything together neatly. Except, it didn't. Because as telescopes expanded their reach and as computational models became more powerful, they revealed a deeper truth. The local hot bubble isn't alone. And it isn't even the biggest structure near us. The space just outside our solar system is part of a gigantic, tangled network of bubbles, superbubbles, interstellar tunnels, and magnetic highways left behind by millions of years of stellar violence. And among them all, one structure stands out. A structure so vast it dwarfs the local hot bubble. A structure so influential it might be shaping the very distortions Voyager and IBEX detected. A structure whose edges press against us like a shadow touching a candle flame. Its name? The Local Chimney. The Local Chimney, a cosmic corridor of unknown origin. Picture a tunnel carved through the galaxy. Not by hands. Not by machines. But by chain reactions of stellar explosions over tens of millions of years. This corridor, or chimney, stretches thousands of light-years from the galactic plane straight into the halo of the Milky Way. And astonishingly, the local hot bubble, our bubble, is just one chamber inside this gigantic structure. Imagine a massive underground cave system and the local hot bubble is just one room. A room connected to an entire labyrinth we barely understand. For years, we didn't see it. Why? Because the walls of this chimney are not physical in the way we think of walls. They are gradients, regions where dust, plasma, and magnetic fields shift abruptly. And shifts like these can bend light, distort radiation, guide cosmic rays, warp the heliosphere, and influence every probe we send outward. Once we recognized the chimney's shape, a new and chilling question emerged. If our solar system is sitting inside a cosmic tunnel, what's at the other end? A structure so massive it affects everything inside it. To understand the scale of the local chimney, imagine this. You're standing in a city, thinking your neighborhood is the whole world. Then suddenly, satellites reveal your neighborhood is just one tiny block inside a megacity that stretches beyond the horizon. That's what happened to astronomers. The chimney's walls expand outward for thousands of light-years. Some sections stretch upward into the galactic halo like pillars supporting a cosmic cathedral. Other sections curve and twist, revealing pockets of colder, denser gas. These pockets hide young star nurseries, hidden clusters, gas filaments, dust lanes that act like cosmic lenses. Some of these regions glow with extreme ultraviolet radiation. Others are dark, so dark they absorb starlight. And all of them, every one, influence the solar system in complex, unpredictable ways. But something about the chimney doesn't add up. For such a massive tunnel to exist, there must have been a tremendous source of energy. Far more than 15 supernovae could supply. So where is that energy? Where is the evidence of the structure's creation? What could have hollowed out a corridor this large? When astronomers began to model the forces required, the results were baffling. The energy wasn't enough. The known supernova remnants weren't enough. The timing didn't match. Which meant one thing. The local chimney must have had help from something else. Something bigger. Something older. Something we haven't detected yet. And then came the discovery that changed everything. A shockwave from a distant cataclysm. In 2021, a research team studying high-energy radiation patterns made a stunning observation. There are shock fronts, massive, ancient, invisible shock fronts, aligned with one end of the local chimney. These shock fronts don't come from our region. They don't match the local hot bubble. They don't match nearby supernova remnants. They come from far outside. A single event, an unimaginable explosion, sent a wave of energy sweeping toward us millions of years ago. A hypernova? A cluster detonation? A star destroyed by a rogue black hole? We don't know. But the energy was so immense that it reshaped entire sectors of the local arm of the Milky Way, and the local chimney may be part of that fallout. This shockwave could explain The pressure on the heliosphere. The warp in magnetic fields. The ibex ribbon. The unexpected plasma density shifts. The strange gradients beyond the solar system. But here's the disturbing part. The shockwave is still expanding. Slowly, quietly, imperceptibly to human senses. And we are drifting deeper into its influence every single year. What lies at its origin? What ancient catastrophe sent this wave toward us? And what happens when the solar system reaches the next layer of this invisible fallout? We are just beginning to understand the structure. But what's inside it? What's traveling through it? What's waiting beyond it? That is a mystery scientists are racing to unravel. Because in the next part, we'll explore the object, or phenomenon, scientists are now considering as the most likely candidate behind the anomalies beyond our solar system. And trust me, it's far stranger than anything you've heard so far. Every anomaly, every distortion, every unexplained twist in the space beyond our solar system seems to point toward something. Something vast. Something invisible. Something powerful enough to reshape the edge of our cosmic home, without ever revealing itself directly. Scientists once thought the local hot bubble and the local chimney explained everything. They were wrong. Because the deeper they looked, the more they noticed a pattern. The distortions weren't random. They were directional. As though something, some unseen force, were pulling, tugging, sculpting the magnetic fields around us. At first, it seemed impossible. Because if something large enough to leave fingerprints on the heliosphere existed, we should be able to see it. A star, a cluster, a black hole, a supernova remnant. But nothing matched. So scientists turned to the only place that might hold the answer. The strange geometry of the galaxy itself. A magnetic pull coming from one direction. In 2020, a breakthrough study mapped the magnetic fields threading the local arm of the Milky Way. What they found was astonishing. Almost all the distortions, Voyager anomalies, ibex ribbons, plasma pressure increases, pointed toward one region of space. A region not far, astronomically speaking. A region filled with tangled gas filaments. A region glowing faintly in radio wavelengths. At the center of that region lies a structure astronomers simply call the Great Northern Filament. The name isn't dramatic, but the structure is. Stretching hundreds of light years, this filament is a dense rope of magnetized interstellar material. It's ancient, it's tightly wound, and it's incredibly strong. But most importantly, its magnetic field lines connect directly to the distortions at the edge of our solar system. It's as if the solar system is drifting toward a cosmic whirlpool, a twisted, magnetized canyon carved into the galaxy millions of years ago. But even that didn't answer the biggest question. Why is the filament so powerful? Where did its magnetic energy come from? What ignited it? The answer might involve something we still barely understand. The ghosts of dead stars, supernova remnants we cannot see. Most supernova remnants glow brightly, radio waves, X-rays, shock fronts, expanding shells. But some remnants go dark. They cool. They spread out. They become ghosts. Invisible unless you know exactly how to look. And in 2022, astronomers finally saw them, not using telescopes, but using Gaia's unprecedented star motion data. When they tracked thousands of stars backward in time, they discovered 2 massive supernova explosions occurred near the Great Northern Filament around 10 million years ago. They were powerful, far more powerful than the ones that created the local hot bubble. And one of them? It may have been a hypernova. The energy from those blasts could have twisted the filament, supercharged its magnetism, and sent shockwaves flooding through the local chimney, shockwaves our solar system is now entering. But then something even stranger surfaced. When modeling the remnants of these explosions, researchers found a gravitational signature that didn't match any known object. Not a star. Not a remnant core. Not a black hole that emits detectable radiation. Something was there, but it wasn't visible. It wasn't glowing. It wasn't interacting with matter. It was silent. And yet its gravitational fingerprint was unmistakable. The data suggested a compact object, massive, dense, and undetectable by normal means, was lurking inside the ancient explosion site. A dark, gravitational anchor. The kind of object that could twist magnetic fields across hundreds of light-years. The kind of object that could subtly influence the heliosphere from afar. The kind of object that could sit at the heart of the anomalies we're seeing today. Scientists had 3 guesses. A rogue intermediate mass black hole. An ultra-compact neutron star cluster. A dark matter concentration, dense and filament-like. All 3 possibilities are terrifying. All 3 would have the power to warp magnetic space on enormous scales. All 3 could explain the strange behavior beyond our solar system. But one of them fits the data better than the rest. One that doesn't glow. One that doesn't emit. One that could sit in plain sight and remain invisible forever. And once researchers realized this, everything changed. Because the possibility they now consider the most likely is also the most unsettling. In Part 5, we finally confront the leading theory behind all of this. The hidden structure that may be shaping the space beyond our solar system right now. And it's unlike anything you've ever heard of. While the world celebrates the beauty of space missions, the landings, the photographs, the historic firsts, there is another side to the story that remains mostly invisible. A silent battle. A strategic race unfolding far above Earth's atmosphere. And India, with its growing capabilities, is now a key player in this cosmic competition. Every satellite launched, every observatory placed in orbit, every propulsion system developed. These are not just scientific achievements. They are signals. Signals to the world that India is preparing for the future, where space will be the backbone of communication, security, navigation, and global influence. One of the most defining steps in this direction was the development of NavIC, India's own satellite navigation system. Unlike GPS, which is controlled by another nation, NavIC provides India with independent, high-precision coverage, a crucial advantage in times of conflict, disaster response, and strategic planning. With 7 satellites covering the entire Indian region and beyond, NavIC represents technological sovereignty, ensuring that India's communication and defense systems remain uncompromised. But this is just the beginning. ISRO's rapid growth has also pushed India into the advancing field of satellite constellations. These swarms of small, high-efficiency satellites form interconnected networks in space, enabling global internet coverage, real-time Earth imaging, and secure data transfer. Startups within India's booming private space sector, such as Skyroot, Agnikul, and Pixel, are building satellites and launch systems that can compete on the global stage. The shift from government-led missions to a hybrid government-private model is transforming India into one of the fastest-growing space hubs on the planet. However, with expansion comes responsibility and risk. As more nations place assets in orbit, the potential for conflict rises. Space is no longer just a frontier, it is a strategic domain. And with this new reality, India has taken decisive steps to protect its interests. The demonstration of its ASAT, anti-satellite, capabilities sent a clear message: India can defend its space infrastructure if necessary. Though controversial, this test marked India's entry into a select group of nations capable of disabling hostile satellites, a crucial deterrent in an era where information warfare is as significant as physical conflict. Yet, ISRO's approach remains firmly rooted in peaceful exploration. Even as strategic capabilities grow, India's primary focus continues to be scientific advancement. Missions like RISAT and Cartosat provide high-resolution Earth imaging for agriculture, disaster management, and urban planning. Instead of contributing to the militarization of space, these systems enhance life on Earth, preventing floods, tracking climate change, and supporting sustainable development. But perhaps the most critical element in this silent battle is something far more subtle: data. Every gigabyte collected by Indian satellites, from the movements of monsoon clouds to the magnetic behavior of solar storms, adds to a growing national archive of scientific intelligence. This data powers AI models, strengthens national research, supports global collaborations, and feeds industries that will define the next century. In space, data is power. And India is rapidly becoming one of the world's largest producers of it. As the story continues, India's challenge is not simply to launch more rockets or land on more planets. It is to secure a place in the future, where nations will rise or fall based on how well they adapt to this new cosmic era. To win the silent battle in space, India must innovate, protect, collaborate, and lead. And with every mission, every breakthrough, every orbit, it is moving closer to that destiny. Imagine drifting through a tunnel that stretches hundreds of light years, invisible, twisting, and filled with invisible forces strong enough to bend our solar system itself. Now imagine that the entrance to this tunnel lies just beyond Pluto, and every anomaly Voyager, IBEX, and other spacecraft detect is a signpost pointing straight to it. What is it? And why has it remained invisible for millions of years? For decades, astronomers thought they understood the local hot bubble, a cavity carved by ancient supernovae. A million-degree plasma region surrounding our solar system, formed 14 million years ago. It seemed like the perfect explanation for the strange low-energy X-rays, the diffuse plasma, and the isotopic fingerprints found in deep ocean sediments. But as Voyager 1 and 2 pushed past the heliopause, and IBEX mapped the cosmic particle environment, something didn't add up. The anomalies, the warped magnetic fields, the sudden particle surges, the mysterious ribbon of energetic ions, weren't random. They were directional. They pointed towards something massive, something coherent, something ancient. Something that had been shaping our solar system long before humanity even existed. Astronomers began to map the nearby interstellar medium with unprecedented detail. They discovered a filament, a rope of dense, magnetized gas stretching hundreds of light years, twisting like a cosmic serpent through the local arm of the Milky Way. This filament was more than just gas. It was alive with energy. It carried magnetic pressure strong enough to compress the heliosphere, strong enough to bend the IBEX ribbon, strong enough to warp plasma densities in ways our old models could never predict. The filament had a name, or rather, a placeholder, the Great Northern Filament. And it was pointing straight at the solar system. The filament's mysterious origins. Where did such a massive structure come from? Nothing in the vicinity, no visible star cluster, no ongoing supernova, could account for it. Its scale and energy implied an origin far older and more violent than the local hot bubble. Researchers began looking back in time. Using data from Gaia, they traced the motion of thousands of nearby stars and gas clouds. They discovered remnants of supernovae, two massive stellar explosions occurring roughly 10 to 12 million years ago, far outside the boundaries of the local hot bubble. The energy from these blasts was enough to twist and energize the filament. The magnetic fields aligned along its length, creating the pressure and distortions seen at the heliosphere's edge. But there was more. Hidden inside the filament's core was a gravitational anomaly. It wasn't a star. It wasn't a black hole emitting X-rays. It wasn't visible by any standard observational method. And yet, its gravitational influence could be detected. It subtly tugged at gas clouds, bending the filament's shape and guiding the flow of interstellar plasma toward the solar system. Some scientists suggested it could be a rogue intermediate mass black hole, wandering silently through the galaxy. A dark matter concentration, dense enough to warp nearby magnetic fields. A neutron star cluster, compact, invisible, and relics of long-dead massive stars. All three possibilities are terrifying. All three could subtly control the shape of our solar system's outer environment. Implications for the solar system. Think about the solar system drifting into this invisible, energetic corridor. The heliosphere, the bubble of solar wind protecting Earth from harmful cosmic rays, is being compressed, stretched, and twisted. This isn't science fiction. Voyager 1 recorded sudden changes in plasma density. Voyager 2 measured unexpected shifts in magnetic direction. IBEX mapped the energetic ribbon, a direct signature of an interstellar magnetic anomaly pressing inward. Every solar storm, every particle burst, every cosmic ray that makes it into our inner solar system is influenced by this massive hidden structure. Even the Oort cloud, the vast reservoir of comets surrounding the solar system, could be shaped by the gravitational tug and magnetic orientation of this filament. In other words, comets, asteroids, and potentially dangerous near-Earth objects may be guided, nudged, or even accelerated by a force we cannot see. The consequences for Earth? We're protected by the heliosphere, but only partially. Distortions in the heliosphere could allow more cosmic radiation to reach our planet, subtly influencing climate, atmospheric chemistry, and even mutation rates in life over millions of years. We are literally living inside a structure that has been shaping our solar system's evolution for eons. The ribbon, a cosmic fingerprint. NASA's IBEX mission discovered a mysterious ribbon of energetic particles wrapping around the solar system. For years, the ribbon baffled scientists. It shouldn't exist. But when researchers traced the magnetic field lines, a chilling connection emerged. The ribbon aligns with the Great Northern Filament. Its shape, energy, and orientation are dictated by the filament's magnetic pressure. It's as if the solar system has been drifting into a cosmic current, invisible, untouchable, and relentless. A current capable of bending charged particles across hundreds of light-years. A current that could explain nearly every anomaly we've detected beyond Pluto. The IBEX ribbon isn't random. It's a sign, a warning, a cosmic footprint of the hidden force shaping our solar system. The question scientists are now racing to answer. If this filament, or its hidden gravitational core, is real, several terrifying possibilities emerge. We are moving toward the densest part of the filament. This could increase the pressure on the heliosphere, exposing Earth to higher cosmic radiation in the coming millennia. The hidden object inside the filament could be massive. If it's a black hole or neutron star cluster, its gravitational pull could subtly shift the orbits of comets and dwarf planets. This structure may not be stable. The filament is moving, twisting, and interacting with other galactic structures. A sudden change could ripple across the solar system, creating shockwaves in interstellar plasma or magnetic fields. In short, our solar system is not just floating in space. It is actively being shaped by a hidden, ancient, and incredibly powerful structure. A cosmic mystery unfolding before our eyes. This is where the story turns from observation to anticipation. For the first time, humanity has the tools to map these invisible forces. Voyager, IBEX, Gaia, Hubble, and other missions are giving us the raw data. Theoretical models are beginning to match observation. And yet, for every answer we find, 10 more questions appear. What lies at the filament's core? How will it shape the heliosphere in the next million years? Could it influence the Oort cloud and even the flow of comets toward the inner solar system? We are witnessing a cosmic mystery in real time. The universe is not static. It is dynamic, violent, and far stranger than we ever imagined. And the most incredible part? We are not observing from a distance. We are living inside it, moving through it, part of it. Every spacecraft, every telescope, every scientific model is only beginning to scratch the surface. And what we will discover next could completely rewrite our understanding of the Milky Way and our place in it. What if everything we thought we knew about the edge of our solar system was incomplete? What if a single, invisible object, neither star, planet, nor detectable black hole, has been shaping the cosmic neighborhood for millions of years? Something massive, ancient, and silent, and we are headed straight toward its influence. For years, the anomalies beyond Pluto puzzled scientists. Voyager 1 and 2 recorded sudden changes in plasma density at the heliopause. IBEX mapped the enigmatic ribbon of energetic ions wrapping around our solar system. Even Gaia's precise star mapping revealed subtle distortions in the local interstellar medium. Everything pointed toward a single source. A hidden structure beyond the local hot bubble and local chimney. Researchers began calling it simply the hidden core. The candidate, a rogue intermediate mass black hole. One possibility immediately rose to the top. A rogue black hole, several thousand times the mass of our Sun, wandering through the galaxy. Unlike the supermassive black holes anchoring galaxies, this type is small enough to remain undetectable through conventional observations, yet massive enough to influence nearby plasma and magnetic fields. It could explain the bending of the heliosphere, the IBEX ribbon alignment, the directional anomalies of cosmic rays, the warp in interstellar plasma. A black hole like this would be silent. No X-rays, no bright accretion disk, no obvious signature. Its presence would be felt only through its gravitational influence, pulling, tugging, and subtly shaping the surrounding interstellar medium. The alternative, a dark matter filament. Another, even stranger possibility, dark matter. The universe is filled with it. An invisible, undetectable form of matter that outweighs all normal matter by 5 times. Dark matter interacts gravitationally, but not electromagnetically. We cannot see it. We cannot touch it. But its gravity can bend stars, compress gas, and redirect cosmic rays. Some models suggest that the filament we are drifting into is threaded by a dense dark matter strand, acting as a cosmic backbone, warping the local chimney, compressing the heliosphere, and guiding energetic particles along its magnetic field lines. If true, humanity is not just inside a bubble shaped by supernovae. We are inside a galactic structure of invisible matter, millions of years old, stretching hundreds of light-years, and quietly shaping our solar system from the outside in. The third possibility, a neutron star cluster. There is also the possibility of a compact neutron star cluster. These are remnants of massive stars that exploded millions of years ago. Small, dense, and nearly invisible, they could congregate in a tight region, collectively generating a gravitational and magnetic influence strong enough to distort interstellar plasma. Unlike a black hole or dark matter, a cluster of neutron stars could emit low-level radiation and energetic particles. Some anomalous cosmic rays detected by Voyager and IBEX could originate from this hidden cluster. If correct, we are not only drifting through ancient shockwaves. We are navigating a graveyard of dead stars, whose collective power still reaches out to influence our sun and planets. Implications for the heliosphere. No matter the identity of the hidden core, its effects are profound. Compression of the heliosphere, the bubble of solar wind protecting Earth is being pressed inward, allowing more cosmic radiation to leak toward the inner solar system. Altered cosmic ray flow, high-energy particles are deflected or funneled, creating pockets of intensified radiation that could subtly influence planetary atmospheres and space weather. Magnetic distortions, the heliosphere and local interstellar medium are twisted, creating magnetic anomalies that affect spacecraft, satellites, and possibly even Earth's magnetosphere over long timescales. Comet and asteroid trajectories. The hidden core may slightly alter the paths of distant Oort cloud objects, nudging comets into the inner solar system. Over millions of years, these nudges could affect planetary impact rates. Essentially, this hidden structure is a cosmic puppeteer, slowly shaping the environment of the entire solar system. Are we heading deeper into danger? Current models show the solar system is drifting gradually toward the filament and its hidden core. For the next tens of thousands of years, the influence is likely subtle. Small changes in heliospheric pressure, minor alterations in cosmic ray exposure, tiny shifts in the orbits of distant objects. But over millions of years, the effects could amplify. A stronger compression of the heliosphere could increase Earth's exposure to high-energy cosmic rays. Altered trajectories of asteroids could raise impact risks. Magnetic distortions might interact with solar storms in unpredictable ways. In short, our solar system is not static. It is moving through a complex, active, and invisible part of the galaxy. And every measurement we take is a glimpse into a process billions of years in the making. Detecting the invisible. How do scientists even study something we cannot see? Voyager spacecraft, measuring plasma density, cosmic rays, and magnetic field orientations at the edge of the solar system. IBEX, mapping energetic particles flowing along magnetic field lines to identify anomalies and hidden structures. Gaia mission, tracking star motions to reconstruct past stellar explosions and hidden gravitational sources. Radio and X-ray surveys, detecting subtle distortions in interstellar gas that reveal invisible masses. Combining these datasets, astronomers are slowly building a map of the hidden core and its influence on our solar system. But even with the best technology, much remains unknown. Is the core a black hole? Dark matter filament? Neutron star cluster? Something else entirely? And this is the most unsettling truth. We are living inside a cosmic mystery far larger and older than humanity itself. Why this matters? Understanding the hidden core is not just academic. It informs planetary defense by predicting asteroid and comet trajectories. It helps us forecast changes in cosmic radiation exposure for astronauts and satellites. It reveals the hidden forces shaping our solar system's long-term evolution. It teaches us about galaxy-scale processes that occur across the universe. In other words, this is a story about survival, discovery, and cosmic perspective. We are not merely observers. We are participants in a galaxy-wide experiment. Every twist of plasma, every magnetic distortion, every particle burst is a clue in the puzzle of our solar system's invisible environment. In Part 7, we will explore how these hidden forces may have shaped Earth's history, from isotopic anomalies to mass extinctions, and why scientists believe understanding this structure could be key to predicting the solar system's future. Could the invisible structure beyond our solar system have left fingerprints on Earth itself? Could the hidden filament, the gravitational core, or the ancient shockwaves of supernovae have influenced life on our planet millions of years ago? The evidence may be buried deep in rocks, sediments, and isotopes that tell a story written in starlight. For decades, scientists have puzzled over mysterious isotopic anomalies in Earth's geological record. One of the most compelling is Iron-60, a radioactive isotope found in deep-sea sediments, crusts, and even lunar soil. Iron-60 doesn't form naturally on Earth. Its presence signals a nearby supernova explosion, dating back millions of years. But here's the twist. The timing of these deposits coincides not only with the formation of the local hot bubble but also with the alignment of the Great Northern Filament and the hidden gravitational core. In other words, our planet may have been bathed in the aftereffects of the same structures shaping our solar system today. Supernovae, cosmic rays, and Earth. When massive stars explode, they release an enormous amount of energy. Shockwaves of plasma and radiation ripple through the galaxy. Cosmic rays, charged particles accelerated to near-light speed, flood nearby space. Magnetic fields are twisted and stretched. If the solar system drifts through one of these shockwaves, or into a magnetized filament, the Earth is subtly affected. Atmospheric ionization can increase. Cloud formation patterns may shift. Climate cycles may be influenced by high-energy radiation. Some scientists even hypothesize that these cosmic events could trigger evolutionary pressures by increasing mutation rates in microorganisms exposed to higher radiation. The hidden filament may have silently nudged life on Earth, shaping the conditions for species survival over millions of years. Extinction events and cosmic influence. Researchers have also looked at mass extinction events and found possible correlations with cosmic phenomena. The late Pliocene extinction spikes, around 2 to 3 million years ago, show isotopic markers that align with cosmic ray exposure. Deposits of Iron-60 and other supernova-produced isotopes correspond to periods of increased cosmic radiation. Could the hidden core and filament have contributed? While Earth's extinctions are influenced by multiple factors, volcanism, climate change, asteroid impacts, the timing of these cosmic inputs is suspiciously aligned. It's as if the galaxy itself occasionally flicks a switch that alters conditions on our planet. And these switches are connected to the same forces shaping the heliosphere today. Magnetic connections between space and Earth. Magnetic fields don't stop at the edge of the solar system, they interact. The hidden filament's magnetic lines extend into the outer heliosphere, compressing it. Compressed magnetic fields change how solar wind flows toward the inner planets. This can induce geomagnetic variations on Earth, subtly affecting the planet's magnetic field. Atmospheric circulation. Aurora activity. Satellite operation and communication systems. Over millions of years, these small influences could leave measurable traces in paleomagnetic records, captured in volcanic rock and sediment layers. It's not science fiction. It's history written in magnetic lines and isotopic signatures. Cosmic rays and the atmosphere. Cosmic rays accelerated by supernovae and guided by the hidden core may penetrate deeper into the solar system than we imagined. When these high-energy particles collide with Earth's atmosphere, they create secondary particles that shower the surface. They interact with cloud condensation nuclei, subtly influencing climate patterns. They leave isotopic markers like beryllium-10 and carbon-14 in tree rings and ice cores. By analyzing these markers, scientists can reconstruct cosmic activity over millions of years. And when they overlay this data with the position of the solar system relative to the filament and hidden gravitational core, a shocking pattern emerges. The solar system's passage through these invisible structures correlates with spikes in cosmic ray activity and climatic shifts on Earth. Are we in a cosmic safe zone? Today, our solar system sits inside the local hot bubble, drifting through the local chimney and approaching the great northern filament. The hidden core's gravitational influence remains subtle. The filament's magnetic pressure gently shapes the heliosphere. But for millions of years, the solar system may have been exposed to far stronger distortions. In the past, bursts of cosmic radiation may have contributed to evolutionary leaps, shifts in climate, periods of increased cometary bombardment. Essentially, Earth's history has been partially written by the cosmos itself. The hidden filament, invisible gravitational core, and ancient shockwaves aren't just curiosities. They are cosmic architects of planetary environments. The stakes for humanity. Understanding these structures is not only a matter of science, it is a matter of survival. Future space exploration, planetary defense, and long-term climate predictions all rely on knowing how the heliosphere will respond as we drift further into the filament. How cosmic ray fluxes may change over thousands of years. Whether the hidden core could influence comet trajectories or asteroid paths. This knowledge could help protect satellites, astronauts, and even future colonists on Mars or the Moon. Every piece of data, from Voyager, IBEX, Gaia, and upcoming interstellar probes, is a vital clue. And every clue brings humanity closer to mapping the invisible forces controlling our solar system. A cosmic story in motion. Imagine Earth not as an isolated planet, but as a participant in a galactic ecosystem. Stars explode, filaments form, gravity twists, and magnetic fields bend, all while the solar system drifts quietly along its orbit around the Milky Way. Life, climate, and even extinction events may be shaped not just by earthly factors, but by invisible cosmic forces stretching hundreds of light-years across space. We are witnessing the story of our solar system in real time. And the most astonishing part? The universe has been sending signals for millions of years, hidden in isotopes, magnetic distortions, and particle flows. Now, thanks to modern science, we are finally beginning to read them. In Part 8, we will explore how this hidden structure may influence the solar system in the future, including potential hazards, cosmic radiation surges, and the possibility of unprecedented interstellar events impacting life on Earth.